Talking about uncertainties, which is a really important component when it comes to experiments. It's essentially a reflection on how well you did your experiment, as it really shows how confident you are about the measurements that you have conducted. So uncertainties can get really complicated when you're calculating, so today I'll be walking through how to deal with that. Here is a brief summary of what I'll be covering today. I'll be covering the difference between fractional, percent, and absolute uncertainty, which is really important when it comes to calculations. I'll be talking about how to calculate uncertainties in measuring tools, such as rulers. Also, how to calculate uncertainties when you're adding, subtracting, multiplying, dividing, square rooting, or squaring, whatever. And also how to find the uncertainties for an average in a range of values. So we're going to first differentiate between fractional, percent, and absolute uncertainties. I think it's better to show this rather than talk about it. So I've given you an example here, which is 138 plus or minus 2. So in this case, the 2 here would be your absolute uncertainty. This is your absolute. This is not related at all to 138. It stands on its own. So this is your absolute. So how do you find fraction? Well, per its name, you would find the fractional value of this. So you would take your absolute and divide it by your value, which is 138. A really important thing is you don't want to keep it as a fraction, you do want it as a decimal. So putting this in my calculator, I get 0.01449 ... I'll just round this to one significant figure just for convenience sake. And percent is really easy. Once you know the fractional, you just multiply it by 100. Now, one thing you want to note is you might realize that the 2 matches with the last significant figure's decimal place in this. And this is just a rule that you want to follow when you're writing your uncertainties. So for example, if I put 140 plus or minus 2, this would not be correct because per significant figure rules, this 0, it does not actually count as a significant figure. This 2 is a significant figure. So you can see that the significant figure decimal places do not line up. So this would be incorrect. So you would have to put it as 138 plus or minus 2 so that it does sync up. All right, now I'll be talking about uncertainties with measuring tools. So I like to split this between 2 different kinds of measuring tools, which I like to call physical measurements and digital measurements. Physical measurements are things that you see and measure yourself. A digital measurement would be like a machine that gives you an actual value. So if you had a really fancy voltmeter, that would actually give you the value, I don't know, 1.05 volts instead of you actually estimating that by looking at it. So how you find the uncertainties for these different measuring tools varies. If you have a physical measurement, the absolute uncertainty is the value of the increments divided by 2. Now, what the heck does that mean? So let's take this example. So right here, I have a pencil that's being measured on a ruler. So let's just say that the pencil is around, it seems like 70 centimeters, right? But now we need the uncertainties. But what is the increment in this case? The increment in this case is these tiny tick marks here. You see that? That's the increment. All right, so we need to know what is the value of the increments. Well, we can see that there are about 5 of these between 10. So there's 5 tick marks between 10. So that would be just 10 divided by 5. So the value of our increment is actually 2. So then the uncertainty would just be 2, which is the value of our increment, divided by 2, which is 1. And this is our absolute uncertainty. And you might notice here that the significant figure decimal places don't line up. So you would actually have to say that this is 1770 with a dot to say that this is 2 significant figures plus or minus 1 centimeter to get it to line up. Or you could say instead 701 times 10 to the 1 plus or minus 1 centimeters. This is a bit longer, but Either way works. So now we have a digital measurements. Digital measurements are slightly easier. So in this case, the absolute value is 1 multiplied by the value's last decimal place. So here we have a fancy voltmeter that gave me the measurement 8.96 volts. So our last decimal place is here. So we just multiply that at 1. So that would just be 8.96 plus or minus 0.01 volts. Very precise and very easy. Alright, so now let's talk about adding and subtracting. This is the rule you need to follow when you have an addition or subtraction problem. So you always add the absolute uncertainties of the two values. So let's look at an example. So here are my examples. Here we have 16.1 plus or minus 0.5 plus 5.8 plus or minus 0.1. So let's just find the actual addition value. So it's 16.1 plus 5.8. And the uncertainty, as you might see, this is already in absolute. So the rule is we add the absolute. So we have 0.5 from the 16.1 plus 0.1. We get 21.9 plus or minus 0.6 as our final value. And here is essentially the same problem, but subtracted. So 16.1 minus 5.8 plus or minus, and even though this is a subtraction problem, we still add the absolute value of the uncertainties. So this would give me 10.3 plus or minus 0.6. So let's look at our third example. In our third example, we have 2.7 plus or minus 0.05 plus 3.5 plus or minus 10%. Notice now that this is a percentage, so we need to convert this into an absolute uncertainty. So that's 2.7 plus 3.5 plus or minus 0.05. And because we need to convert this to an absolute uncertainty, this would be 3.5 divided by 0 times multiplied by 0.1 because this is 10%. And that would be 6.2 plus or minus 0.4. Okay, multiplying and dividing is slightly more complicated. In this case, you always add the percent or fractional uncertainties of the two values. So the reason why this one is a little bit more complicated is, again, usually they give it in an absolute uncertainty, so you would have to convert it to fractional or percent. And because you add the percent or fractional, you actually only find the percent or fractional uncertainty, and you'd have to convert it back to absolute again. So let's look at an example. So here we basically have the same problem, but now they're multiplied. So this would be 16.1 multiplied by 5.8 plus or minus. And because these are in absolute, we have to convert it. So this would be 0.5 divided by 16.1 plus 0.1 divided by 5.8. And this would be our fractional uncertainties being added together. And obviously we need to follow sig fig rules. So 5.8 has two significant figures, 16.1 has 3, so therefore our final answer would have 2 significant figures. And because this is only our fractional uncertainty, we'd have to multiply this by our final answers. So by 93, and I like to put the extra decimals just so it's a little bit more precise. So this would give me 93 plus or minus 5. Okay, now let's look at uncertainties when you have powers or roots. This one is pretty simple. You multiply the fractional or percent uncertainty by the power. So let's look at an example. Alright, so here we have 0.15 plus or minus 10% to the power of 3. Since I used a fractional uncertainty example last time, let's use a percent one. So Now we have 0.15 to the power of 3 plus or minus, since it's power of 3 times 10%. 0.15 to the power of 3 is around 3.375 times 10 to the negative 3 plus or minus 30%. Now obviously we need to convert this back to absolute, but let's first get the actual value. So this would round to two significant figures because 0.15 has two significant figures, and this would be plus or minus 0.1 times 10 to negative 3. And you might be wondering, what about square roots? Now, remember that if I had 0.15 square root, that's essentially just 0.15 to the power of 1 over 2. So the uncertainty, which in this case would just be 1 over 2 times 10%, which is just 5%. So keep that in mind. The rule still stands. Okay, finally, I'm going to talk about uncertainties for averages. So the absolute uncertainty for an average is the worst range within the values divided by 2. Okay, let's look at an example. Here are three values, 166, 170, and 165. Let's first find the average of these values. So the average in this case would be 166 plus 170 plus 165 divided by 3, which gives us 167, a really nice number. Now let's look at the uncertainty. So you might be confused as what the worst range is. Essentially, the worst range is basically the largest difference between two values within these three values. So in this case, the worst range would obviously be the largest number, which is 170, subtracted by the smallest number, which is 165. Range divided by 2, which is essentially just 5 divided by 2, which gives us 2.5. And again, because we need the decimal places of the significant figures to line up, this would be 167 plus or minus 3. So that's basically all you need to know about uncertainties. It's pretty simple once you get the hang of it. So do some practice and ask some questions if you have any, and I wish you all luck with your experiments.